It is 2 in the morning. A production server is in a rack you cannot reach, a cloud region you cannot walk into, or a closet 3 floors away. You need to log in, read logs, restart a service, maybe copy a fixed config file. But the network between you and that server is shared by switches, routers, Wi-Fi, VPN gear, and people you do not control. How do you administer the box without spraying your password in commands across the wire in readable text? That is the problem SSH solved. SSH stands for Secure Shell. In plain terms, it gives you a remote command line on another machine over an encrypted channel. Before SSH, administrators commonly used telnet, rlogin, and related tools. Those protocols sent usernames, passwords, and commands in plaintext. Anyone positioned to observe the traffic could read the session. SSH replaced that model with encryption, server identity checking, and stronger authentication. On Linux and Unix systems, SSH became the standard management door because servers often have no desktop, no keyboard, and no local human. If you run fleets, cloud instances, storage appliances, network gear, or small lab VMs, SSH is the common language. There are 2 sides. The client is the program you run, usually named SSH. The server is a daemon on the remote machine, usually sshd, listening by default on TCP port 22. When you connect, the client and server negotiate encryption and verify the server host key. That host key is SSH's way of saying, "Am I talking to the same server as last time?" After the encrypted channel exists, user authentication happens. With a password, the password travels inside the encrypted session. With a key, your private key stays on your machine, and the server checks a signature against your public key. After authentication, SSHD starts a shell, a file transfer subsystem, or a tunnel. Here are the first lines to know. The first command says, run the SSH client, log in as user, and connect to server on the default port, which is 22. The second command makes the port explicit with -p22, useful when reading scripts or when a server uses a different listener. The third line copies a file to the server. The scp command still exists, though modern OpenSSH may use SFTP internally. The last line, SSH-L, creates a local tunnel. Connections to your local port 8080 are carried through SSH to port 80, as seen from the server. Same tool, same encrypted channel, different job. A normal first SSH story looks like this. You build a new Debian or Ubuntu VM. During install, you enable openssh-server or install it right after boot. Your firewall allows TCP/22 only from your Office VPN or admin subnet, not from the whole internet if you can avoid it. From your workstation, you run SSH admin at that VM's name or IP. Once in, you update packages, inspect services, and copy a config file into place. Later in this series, we will replace passwords with keys, restrict who can log in, record useful logs, and make this repeatable with automation. The pattern is simple: connect, authenticate, administer, exit. The common mistakes start early. First, do not blindly accept host key warnings. If SSH says the server identity changed, stop and verify why. It might be a rebuild or it might be a path you should not trust. Second, passwords are convenient, but they invite guessing, reuse, and phishing problems. Keys are usually better, especially with passphrases. Third, permissions matter. The .ssh directory should normally be 700, private keys should be 600, authorized _keys is commonly 600. Fourth, exposing port 22 to the entire internet will create noise in your logs. That is not panic by itself, but you need policy, rate limits, and monitoring. This episode is the vocabulary layer. You now know the nouns: client, server, SSHD, port 22, encrypted channel, password authentication, public key authentication, shell, file transfer, and tunnel. The next foundation episodes make this practical: installing OpenSSH-server, making your first clean connection, understanding known hosts, and generating keys. After that, we move into administration and defense: SSHD config, disabling risky defaults, limiting users, logging authentication events, forwarding safely, and automating access across fleets. SSH is small enough to learn quickly, but deep enough that sloppy habits last for years. For a safe 5-minute lab, use your own Debian or Ubuntu VM. Do not practice on someone else's host. Install the OpenSSH server package with the first line on screen. The second line enables and starts the service named SSH, which is the Debian and Ubuntu service name. On Fedora or RHEL family systems, the package and service are usually named openssh-server and sshd. Then run ssh localhost. You are connecting from the machine to itself, but it proves the client, server, port, encryption, and login path all work. After you land on the remote shell, run whoami if you want, then type exit. 3 beats to remember. First, SSH is how administrators get a remote shell without sending the session in plaintext. That is why it replaced telnet and rlogin. Second, SSH is a client and server system. Your SSH client connects to sshd, usually on TCP port 22. Then, encryption and authentication happen before work begins. Third, SSH is not only an interactive shell, it also moves files and carries tunnels for legitimate administration. Tomorrow we keep building from zero, install OpenSSH cleanly, and make your first real connection. New SSH Mastery episode daily on this channel, plus the daily ranked CVE brief for defenders who need to know what matters.